And this is really something weird. I hope something weird just happened, because right now it feels like I'm doing everything sort of in reverse, which is really, really weird. Yeah, something went weirdly wrong. I have no clue. But now everything is sort of performing the way you expected. So I'm still a little bit wondering about what's going on with the Z fighting. But again, that might just be the modulus operation being a little bit weird. But at least the sphere looks right now. And yeah, we have the cube inside, but that's because we're still rendering that cube. But apart from that, we actually have a nice interior here, where we don't render anything. So we're just gonna do a quick little test to verify that we're not doing weird stuff. So if we go to our vertex shader here, and we add a half to the color, then we shouldn't get sort of the transition between 0 and 1 on the edge. We should get it in the middle. And that should mean that the modulus is continuous around like a half, but not continuous around the transition between 1 and 0. So that should fix up that if it's the modulus operation giving us this. It looks really funky. I think it's the modulus. It doesn't really look like Z fighting that much. There's too much of a pattern to it. And again, there's probably also a pattern to Z fighting when it happens. There we go. So that's just wonderful. I think what we're going to do now is we're just going to take 10 minutes of break. And then when we come back, we're going to do a little bit of texturing work, and we're going to see if we can apply a texture to these blocks. But now, we're going to take something like 10 minutes worth of break. And we're back from a little break. So now we are going to try and, what you'll be seeing is that I've opened the GIMP. We're going to try and do a little texture. And this is probably going to end up horrible, but we're going to try it anyway. Going to try and see if we can't sort of emulate a little bit of stone. We're going to go for something that's about 128 by 128. So it looks like this. And we're just going to see if we can't do this as simple as possible. We're going to go for a little bit of noise. That was my idea. I think we want to go for render. Clouds plasma is what I want to go for. We'll go for something like that. Now that doesn't really look very much like stone. So our next little trick is that we are gonna desaturate. So now it's at least sort of black and white. So that's a good thing. Now at this point, we probably want to mess a little bit with the colors. What we're going to do is we are going to go for the curves. Want to get it a little bit. No, we're not going to go for curves. That doesn't really work. Because what I kind of want to do is I want to lower the dynamic range so that we get something that's generally brighter than this. What we could in theory do is if we go for put a black layer behind it, which is my foreground color. If we put that below, then we can do a little bit of opacity work here. So that'll darken it. Just maybe something like this. Then if we put a white layer on top, and play with that opacity, we can get something that's sort of gray. Like to have a little bit more depth in that. Maybe something like that. Call that a stone texture. Yeah, I think we'll do that. We'll just save it out later. It's not going to be tileable or anything like that. We'll take care of that in a bit. So I'm just going to save that out quickly as an asset for us. I'll create a textures folder here, and it's going to be called stone. And export it. Now we're going to export it as something really simple, something called PNM, because I can't be bothered really loading advanced textures right now. And we're going to export it like that. So if we switch back to our code, like this, we now have some new assets. We have a texture, we have a stone.pnm. If I try to open it, it actually shows me the PNM picture, which was not exactly my plan. I was kind of hoping to show you the actual texture, because it's just text, like really simple format to work with. So if we just transition over here, we just find the file format for PNM, because it is here. Consists of a magic number, which is the characters P6. Then there's a space, then the width as ASCII characters, the space, the height as ASCII characters, space, a maximum color value, which will be 255 in this one, again, ASCII. So, and then a single white space character, usually new line, and then it just consists of like a raster of height rows from top to bottom. So it's gonna be, this one's, I think I asked it to export in ASCII, so these are probably gonna be not as bytes, but as characters. So, for images, I don't want, so we're gonna try and load that image in. And then we're gonna try and see if we can't texture our blocks with it instead of our, I mean, I really love this texture that we're running with right now with the weird colors. So that's what we're gonna try and do now. So we're gonna try, and we're gonna again go for a new class called a texture. So for a texture, we are going to want to do a constructor. It's going to take a file name. And we're going to do that as a const. And I can't spell const. As usual, I can't seem to spell anything. So I want to include string. And we're just going to do a really simple test where we just instantiate it and create one just to try it out. So when we're done with all of this, we want to create a texture C. We're going to load it as, and this was texture stone.pnm, textures/stone.pnm. And yes, I want to import texture or include texture. So this should at least sort of compile. It's going to fail at linking with an unresolved symbol because we haven't implemented this yet. but that's what we're going to do now. So what we want to do is we want to make our texture constructor here, and we are going to be working with file streams. So we want to include fstream, and what we're going to do is we are going to start an input file stream. So this is our stream. We're going to open this file. We are going to open it for input, and we are going to open it as text. Which I don't have to specify because it's default. I need to save its binary. So what we're going to start by doing is we're going to pull in our magic number here. So we're going to pull in the magic, which is done thusly. I would suspect at least. And then I'm going to want to just print out the magic just to sort of validate that we've got something that at least somewhat works. So to output that, we also need to include IOStream. Yeah, lots of errors. So we can't read from an IOStream like that into a string. So what we're going to have to do is take a look at, because what we want to do is we kind of want to read the first token. Thing is, we want to read up to sort of the first white space. So we could do it as a loop, essentially. So what we'd do is we'd have a character C, and then we'd initialize that. Like, no, we're not going to initialize it. We're going to do this as a do while instead, because I want to execute at least once. And we're going to keep this as long as it's not the case that A is blank. So as long as we're not a blank, we're going to keep doing this. And what we're going to do is that we're going to read a single character from our stream.get, and then we are going to append that to our magic. So that should read our magic value in. At least we're not getting any errors. We get magic P3. So this document we had a moment ago was P6, which is because it's in binary. We're not doing the binary version. We're doing P3, which is the version we like. So we're just going to assert that magic is P3. And yes, we need to import that and out. That is in C assert. There we go. Now once that is done, what we get is we get a width and a height and a maximum color value. So we're going to want to read those in. So that's width, height, and max color. And this should be able to do with the get from. Oh, now I know why I'm failing, because it's this way around. And from the screen, read width, read height, and read the max color. So, having read that, our image should be width times height at a max color of max color. So I just want to see, now that I remember how to do this, whether this would actually have worked as just stream put to magic. So let's compile. Let's give it a go. Magic is P3. Our image is 0 by 17, which seems very wrong. So what we need is we need the PNM P3 file format, which is PPM. Or is it? Because this is still describing the P6. Here, plain PPM is what we want. So this is the one we're using. This is the rare format because it's awfully simple to work. So we need to sort of skip comments, it looks like. That might be what's going wrong. It's at least reasonable. So how to skip that? So what we want to do at this point, after we've done that, is that we want to say that if we can peek at the stream, take a look at the next characters. As long as this, so actually what we want to do is we want to just print that out so that we can see what we're dealing with. Because odds are there might be some white space or new lines or other weird stuff that we have to skip over before we can see the comments. So we're looking at a character 10. Character 10 is a new line. So what we're gonna do is we're gonna go while standard is blank, this next character. So as long as the next character is blank, or the next character is a hash here, then we are gonna take a look. If it is a hash, then we're gonna want to start a other loop. Else, if it's just a blank character, we just read it and skip it, because then it's not really interesting to us. So if we have the hash symbol here, meaning that we're now looking at a comment, what we want to do is we want to skip forward until the end of line. So what we're going to do is we're going to basically while stream get is not a new line character. We are essentially going to do nothing. So that did nothing. So the question is, are we actually skipping it? Let's try and build. Nope, we're not skipping it. So new line does not qualify as blank. So maybe there is something better. So is blank. So that's space and horizontal tab are classified as blank. There is space. That is what we want, because that includes new lines. And so is space includes tab, new lines, and space, which sounds reasonable. So we're going to skip through that. try that again. Yeah, that looks to me like the start of an infinite loop. So, we've probably managed to do an infinite loop, which is not ideal. Yeah, it's just skipping 10 forever. Which is interesting, because in that case we should hit this one. So we should be calling stream.get, which should go to the next character. So I'm just going to print out next to validate that we actually enter this sort of this branch of the if statement. I mean, we should, but that's not necessarily a guarantee in any way. Now we just have to wait for the browser to time us out so we can stop. Yet, doesn't look like we're entering that. So I would expect sort of if we do it like this, we're either going to hit the first, the second, and then we're going to end here. So I'd really like to see some of this get output, but no matter what, we should be calling stream.get. And now we are. So we're skipping 10 by going into the second, then we see a comment, so we end that, and then we get a 128 by 128 at 255 colors, which is exactly what we want. So I'm really weirded out by this, because the fact that I'm printing should not have an effect. So we're just going to try a little bit back and forth here. That did not change anything. So neither did that. And this last one. So apparently it has an effect whether or not I print here. Which is interesting if you ask me, but we're gonna leave that in for now and then wonder about what's going on later. So now we have the size of the image. We are just gonna assert again because I want to be sure that the max color is 255. Then let's see what we've got in the documentation here. So each sample is represented as an ASCII decimal number. Each sample of the raster has white space before and after. There must be at least one character of white space between any two samples, but there is no maximum. So the idea is that we should be getting, we're going to assume we're going to get them in the same order as the binary format, which means we get height rows from top to bottom, and then each row consists of width pixels from left to right, which is then red, green, blue. So for our texture, I want to define a color. So we are just going to have a structure color here, which is Actually, I think what we're gonna do, and this is where it gets interesting, is that we are actually gonna type that color. So that color is a GLM vec4. Because it's another vector. So we want the GLM slash vec4 header here. And I'm pretty sure I've got this the wrong way around now. So GML vec4 as color. Because then we're going to have a couple of private fields. We are going to have a size T for the width, for the height, and then we are going to have a standard vector of colors, which is going to be the image itself. Yeah, I need to include vector, at least if I want my editors to stop complaining. So at this point, we can start working our way through it. And rather than having width and height being local variables, we're just going to assign them to the fields. So we have height rows. So for size T y equals 0, y less than the height plus y. And then we're going to have the x coordinate here. Afterwards, an x is based on width. Then we are going to go with our, actually what we're going to do is before all this, we're going to go for our image and have it resize so that it is now width times height colors big. Because that means we can just index into it and say y times width plus the x coordinate is a GLM vec4. Now we need to read in the colors. These are going to be integers. Quick little thing here, this is probably not what we want. We probably don't want floating point color in this case. GLM. We probably want integer colors because I'm pretty sure that the texture matrix or texture part of OpenGL is going to be rather unhappy if we try to pass it floating point textures. I mean, I'm sure it's doable, but it's probably not a fast path through the graphics driver. And we want to hit the fast paths or we're gonna be really, really sad. That's sort of the way graphics programming works. You either hit the fast path or you're sad. Those are your choices. There are no other options. And personally, I prefer not being sad. So, let's see. Because otherwise, we're just going to define a color ourselves. I mean, there's a bvec4, which could stand for byte vector. So, yeah, no real description of it. So, Google to the rescue. So B is for booleans. That is not quite what I was hoping for. IVEC is some sort of integer vector. Okay, so a color. We are going to say a color is a GLM T vec4 of unsigned 8-bit integers. variable size object may not be initialized. Yeah, we need to do that in a moment. So what we need to do is we need to read a uint 8e, a red, a green, and a blue. So what order was red, green, and blue? So from our stream, we are going to read red, green, and blue. And then we are going to initialize our vector with red, green, blue, and an alpha channel of 255. We want it to be fully opaque. Transparency is so overrated. Let's see what happens if we try that. Well, no errors. That is a good start.